Okay, so we are going to move ahead into section 2, lesson 2 of chapter 7. We're going to be talking about properties of parallelograms. This is a 2-day lesson. The second day we'll be focusing on proofs. Okay, so let me present my screen and we'll get started with day 1. All right, so we're going to start with vocabulary, which is defining a parallelogram. Okay, a parallelogram is a type of quadrilateral. It has 4 sides. So parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so a parallelogram, 4-sided figure with both pairs of opposite sides parallel. All right, so based on the definition, I know this. Again, it's a 4-sided figure with both pairs of opposite sides parallel to each other. So that's what the definition tells us. Then we have a bunch of theorems that give more facts and more information about our parallelogram. Okay, so I'm going to move down. All right, so next we have the first theorem, which tells us that opposite sides are congruent. So if a quadrilateral, if a 4-sided figure is a parallelogram, its opposite sides are congruent. So first off, as soon as I know that this is a parallelogram, then by definition, I know that opposite sides are parallel, right? That's what we read in the definition. But now, based on this theorem, I now know that opposite sides are congruent. So side PQ is congruent to side RS. This side is the same length as this side. And then top and bottom. QR is congruent to PS. The top is congruent, is the same length as the bottom. Okay, so this is what that theorem tells us. All right, so we have try these problems. All right, so find the values of A and C. Again, the direction should say given parallelogram ABCD, find the value of X, Y, and Z, or find the values in this case of A and B. Okay, so again, if this is a parallelogram, I know that opposite sides are parallel and also congruent. So these are the markings I'd be able to mark on my diagram based on the information I know so far. So I know that A is 12 units long because this side is 12 units long. And I know that B is 7 units long. So A is equal to 12 and B is equal to 7. All right, in the next diagram, I know that A is equal to 6 and B is equal to 5 because opposite sides of a parallelogram are congruent. All right, in the next diagram, I know that A is equal to 20, and because I can mark those congruent, and then I know that 2B is equal to 28, and then I can solve B dividing both sides by 2, so therefore B is equal to 14. Okay? All right, let's move on to the next theorem. So the next theorem gives us even another fact. So again, it says here I have a quadrilateral that's a parallelogram. Before I even read any further, so far, what do I know? If this parallelogram, opposite sides are parallel, right? Opposite sides are congruent. It's going to get kind of messy, right? And now the theorem tells us that if this is a parallelogram, then opposite angles are congruent. So angle Q is congruent to angle S. They're the same measure. And angle P equals the measurement of angle R. Okay? So now you have another fact. All right. So in this next example, oops, didn't mean to grab that. In this next example, you can see over here, they have a parallel. It's like a lamp with that adjustable neck, right? The arm is adjustable. And you can see this parallelogram is drawn. Okay, so it says, suppose you adjust the lamp. So the measurement of angle the measurement of angle S is 64 degrees. what is the measurement of angle R in the parallelogram? So I'm going to just redraw that parallelogram a little bit larger. So I'm just going to sketch it off to the side here. Okay, it doesn't have to be exact and perfect, just a little sketch. So here I have P, Q, R, and S is given 64 degrees. And they want to know what is the measurement of angle R, this angle right here. Okay, well, first off, let's just go through what we know. It's a parallelogram, so opposite sides are parallel. Opposite sides are congruent. Opposite sides are parallel. Opposite sides are, oops, I should have only used one tick mark. Let me fix that. All right, so one tick mark, one arrow. Opposite sides are congruent and parallel. I also know that opposite angles are congruent. So angle R is going to be the same thing as angle P, and angle Q is equal to angle S, okay? Now, we haven't talked about consecutive angles yet, but we already know something about them. All right, angle R and S are what we call consecutive angles, or S and P are also consecutive angles because they are next to each other. One comes right after the other if you're moving in a clockwise direction or a counterclockwise direction. So Q is consecutive to P and R. R is consecutive to Q and S. P is consecutive to Q and S, okay? So what do we know about consecutive angles? Well, let's go back to our parallel lines cut by a transversal, right? Parallel lines. Here's my parallel lines cut by my transversal. So what do we know about this angle and this angle right next to it? Those are consecutive angles of a parallelogram, right? S and R. They're the same thing as our same side interior angles. And we learned that parallel lines implies that same side interior angles are supplementary. We learned about that in our parallel line unit, okay? So in our parallelogram, we can come up with the conclusion that consecutive angles are supplementary, okay? So these two angles are supplementary. The measurement of angle S plus the measurement of angle R equals 180. You can do some substitution. 64 plus the measurement of angle R equals 180. Oh, why did I write 8? My brain is moving faster than my hand. So R equals 180. Subtract the subtract the 64 from both sides, and you're left with 116 degrees. All right. Is there another approach? Because maybe you're sitting there thinking, I would have done it differently. There's another approach. Let's talk about it for just a second. In yesterday's lesson, what did we learn that the 4 angles have to add up to in a 4-sided figure in a quadrilateral? They have to add up to 360 degrees, right? And if you already know that this angle here is 64 and this angle here is 64, couldn't you do 360 minus 64 minus 64? Or if you want to add the 64s up together, right, you would get 360 minus 128, right? And then what you're left over with is what P and R have to add up to, right? So what you're left over with, you would then divide by 2 to get the measurement of angle P and the measurement of angle R, which is going to give you your 116. Okay, so there is another approach if you want to use that fact instead. Okay. All right, let me keep on moving along. Okay, so we have another theorem. It says parallelogram consecutive angle theorem, which is what we just discovered. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So this is just illustrating exactly what we just discovered. Okay, so angles that are next to each other are going to be supplementary to each other. X and Y add up to 180. Y and X add up to 180. So again, it's a parallelogram. We know that opposite sides are parallel. We know that opposite sides are congruent. We know that opposite angles are congruent. And now we know that consecutive angles are supplementary. And all 4 angles add up to 360. We know that from yesterday's lesson. Okay, so lots of facts that we now know. All right, so in 5, 6, and 7, we want to find the measurement of angle X, and there could be more than one approach for each problem. Okay, but we're going to use the fact that consecutive angles are supplementary for these because it's probably the fastest approach. So if consecutive angles are supplementary, that means that 60 plus X has to equal 180. So subtract 60 from both sides and you get X is equal to 120. And number 6, consecutive angles are supplementary. So X plus 115 equals 180. Subtract 115 from both sides, you get X equal to 65. Okay, and number 7, consecutive angles are supplementary, so 85 plus X equals 180. Subtract 85 from both sides, you get X is equal to 95. Okay. All right, that moves us into our last theorem for the day. Excuse me. So now we have a fact about the diagonals, right? If I draw the diagonal from P to R, and then the diagonal from Q to S. This theorem tells us that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So this diagonal is cutting this one in half, and this diagonal is cutting this one in half, which you can tell by the tick marks. Okay, so it's another little fact that we're going to have to remember. So based on the fact that diagonals are bisecting each other, it says in the diagram at the right, PQRS is a parallelogram. Find the values of X and Y. So we just learned that the diagonals bisect each other. So I know that ST is equal to TQ, right? This segment is equal to this one. So I can set up X plus 1 is equal to Y. Well, I'm stuck because I have 2 variables in that equation. Okay, let's try the other equation. I have PT is equal to TR. Right, this segment is equal to this. So I'm going to have 3y minus 7 is equal to 2x. All right, well, that equation also has 2 variables, 2 unknowns. So I'm going to have to use Algebra 1 systems of equations to solve. Okay, since I know that y is already isolated, y is equal to x plus 1, I'm going to substitute the x plus 1 in for the y of the other equation. This is substitution, solving the system by substitution. So I have 3 times the quantity x plus 1 minus 7 is equal to 2x. Now I have an equation with all x's. I know how to solve this. Distribute the 3 in. So 3x plus 3 minus 7 is equal to 2x. You're going to do your subtraction. So you're going to get 3x minus 4 is equal to 2x. Subtract 3x from both sides, so negative 4x is equal to negative 1x. Therefore, x is equal to 4. Okay. All right, so now that I know x is equal to 4, I can plug that back in up here. 4 plus 1 is going to equal y. So that means 5 is equal to y. All right, so now I know x is equal to 4 and y is equal to 5. Okay, then it says, after you do all that work, what's the value of PR? Oops. PR. And then SQ. Well, let's do PR first. PR, using segment addition, PR is going to equal 3y minus 7 plus 2x, right? So let's do some substitution. So the y value is 5. And the x value is 4. So now I have 15 minus 7 plus 8. You're going to have 8 plus 8 to get 16. Okay, so I know the length of PR is equal to 16. Okay, let me make a little room for myself for the last part of this problem. The last part of this problem says to find SQ, the length of SQ. Well, again, using segment addition, SQ is equal to ST, which is x plus 1, plus TY, which is y. So using substitution, I'm going to have 4 plus 1 plus 5. So SQ is equal to 5 plus 5, which is going to give you a 10. Okay. All right, guys. So that is the last bit of the information I'm going to show you from lesson 7.2. There is tons of extra problems here. If you're looking for extra practice, you can always give them a shot. You can always jump onto a Google Meet with me during 12th period if you have questions. But hopefully that all made sense to you. And I will see you back here for the next lesson. Bye.